Alright, welcome back to Maths Digest. Today we are looking at algebraic fractions. Algebraic fractions are those fractions that has their denominator as an algebraic expression and their numerator may or may not be an algebraic expression. We have an example like this. This is an example of algebraic fraction, but this is not. Okay? This is an algebraic fraction. This is not. Okay? This is an algebraic fraction. Why this is not? So these are comparisons, okay? So quickly before we go down to giving you examples on algebraic fraction, if you have not subscribed to this channel, please kindly do that. You can equally go back and watch other of our topics so that you can align well with us, okay? Now, if you want to simplify fractions, algebraic fractions, what is actually asking is to give it, take it to its reduced form. Okay. Now we look at example 1 here, example 2. The first example 1 says 1 over a plus 1 plus 1 over a minus 1. Now let's go down to this. Let's take the first one. Okay, so quickly what we do is this. We're going to find the LCM of the denominators. Okay, now remember what I taught us in the last class. When you talk about LCM, what you simply do, you take it to a table. Those denominators you wish to find the LCM, you take it to the table. Though you can only do this if they are not the same. If they are the same, you can use one of it as the what? As the LCM. But since the sign at the middle differs, so we take them as a separate entity. Okay? Now, looking at this, we can use a plus 1 to what? To cancel out. This can only go in this. We have 1. Now we go for what? The other one, which is a minus 1, which will reduce all of them to what? To 1. So with this, we take the product of this 2. That serves as our LCM, okay? Which is this serves now as the LCM. So what we do is we take it down, and use this to divide them. Okay. Now, this into this, we only have this cancelled off. Okay. So what will now remain is this. So what you do is you use this and multiply the numerator of that particular one. So this, we say 1 into a minus 1 plus. Now we come for this. This can only cancel off for this. We have this left. Okay, so 1 equally, we can say 1 times this. Times this rather, this. Okay, so with this now we have Okay, now looking at this, we have a minus 1 plus a plus 1. We still return back the word, the denominator, which is the LCM. A plus 1. A minus 1. Okay? Now, what we now do is what? We look for the like terms here. Okay? Looking at this, this is a plus a. We take these two together, okay? We say so, sorry, this is a, please. Okay, now a plus a will give us what? 2a. 1 apple plus 1 apple will give us 2 apples. Okay, now we have equal to 2a. Okay, now minus 1 minus 1. If you are owing $1 and the one you have is $1, you use it and pay off. What you have left is what? Nothing. So you only have 2a here over. This is the final answer. Please remember, when you are dealing with the LCM, the denominator here, which is the LCM of the fraction, it remains unchanged to the end of what? Of the expression, okay? So there are still exceptions to this, you see, because this is difference of two squares, okay? Though we're going to talk about that maybe in our subsequent class, difference of two squares. So if you are on OBJ and your answer falls on this, please use it. But if you didn't see something like this and you know you solved well, please note that this can equally be written this way: 2a all over a minus 1 squared. Okay, so if you stop at this, they are good to go. Okay, all right, thank you very much. So quickly we are going to take the second example. Okay, so stay tuned. Okay, this is number 2 now. If you look at this number 2, you find out that the denominator is quite different from the first one we solved. Okay, so this one we find LCM. Now we get to our chart again. We have 3y, we have 4y. Okay, now looking at this, we can see that the coefficient of the y here are not the same and they cannot divide each other. So what you do is what? You still give them or take them as a separate entity. Now you say 3y into this, you can cancel only this. We are still left with our 4y. So we come here, say 4y 1 1. Okay, now we're going to take the product of these two. Now we're not going to leave this 3y in bracket 4y, rather we're going to multiply it. Okay, so when you multiply this, now we have 12y squared. Okay, 12y squared. I believe you understand this. We are doing multiplication. The coefficient multiply each other. Why this y and the other y? Multiplication will give you this. But addition will just take only what? 1. So we are on multiplication. Take note, please. All right. So 12y already we have there. Now coming to this, 3y into this, we have 4y. Okay, so 4y then plus 4y into this, we have 3y. 3 times 3y. Okay. Now looking at this, now we go down and we multiply out what we have in the brackets. Okay. So this will give us, this times this will give us 8y. 8y. Okay. Plus this times this will give us 9y. So we still bring down our what? Our denominator, the LCM. Okay. So with this now, we add up what we have at the numerator side. We have, now we are doing addition, okay, please. This plus this. I have 8 yams. And again, I have another 9 yams. So what I have, I'll add it together. Okay, this will now give me what? 17y. 12y squared. Okay. Now, so looking at these two, you see that we have y at the numerator side and we have 2y at the denominator side. So one y will cancel each other here and cancel y squared here, leaving only what? 1y. We are doing division this time. So what we have now left is 17, 12y. At this point, this is our final answer to this, to its reduced form. Okay. Thank you.